Hi all, today we are going to see about OSPF. Let's get into the video. First of all, what is an OSPF? OSPF is nothing but it's been expanded as Open Shortest Path First. It's a link state routing protocol, while RIP and EAGRP are distance vector routing protocol. OSPF has a process ID. It uses a process ID. What is the process ID? It's just an identity for a OSPF configuration. That's it about OSPF process ID. Next, it also uses a metric. You have already know about what is a metric, and OSPF uses a metric called as a bandwidth. It's totally based on the bandwidth. What is the metric formula to calculate our OSPF is reference bandwidth by interface bandwidth. The lower the metric is better in order to reach a destination through OSPF. It mainly works based on the areas. OSPF works based on the areas, and the neighbors are formed within the same areas. Not within the same areas. The areas of the interface should have to be same in order to form the OSPF neighborship. There should be a area 0 in the network, which is said to be as a backbone area. Every area, not every router, every area should be connected to the backbone area in order to communicate with the OSPF. Once again, it should be every area. Okay. Every area should be connected to the backbone area, area 0. Otherwise, it will not form a routing will not be done. That's the main reason behind inconsistency over here. And OSPF will generate a LSA, which is nothing but a link state advertisement, which is nothing but which are all the routes that it has been having, or it has been connected to the interfaces that will send advertisement to the other OSPF neighbors. And the other router will send the same thing. That is, what are the routes, what are the networks that it is having, it will just send it, and both of them share the advertisement, and the table they maintain is to be as a link state database of the advertisement which they have received. To be more clear about it, let's check it over here. See, there are two routers, R1 and R2. They share the link state advertisement. That is the networks, which all the networks that they are having. They just share it with each other, and this information will be stored in a database. The database, which we call as LSDB, which is nothing but a link state database. That's what is given here. LSA is a link state advertisement, which is just advertising its information, and LSDB is a database that maintains this advertisement. Okay. Next about this, it's DR and BDR. Just consider you have a 10 routers. Let's consider from R1, R2, R3, R4 till R10. They have been fully meshed. Fully meshed in the sense R1 is connected to R2, R3, R4, R5, R6, R7 till R10, and R2 is again connected to all other routers, and R4, R5, R6, R7. Every other router is being connected to all other routers. So what happens is that whenever they send a traffic, if R1 is sending a traffic to the routers, it will be distributed to all others. It will create a huge OSPF traffic. So in order to avoid that, there is some concept called as a DR and BDR. So what does it do? DR in the sense is a designated router, and BDR is backup designated router. So instead of sending a traffic, OSPF traffic to all other routers in the network, so it consider R5, if it wants to communicate to R6, it will send to only R1. It will not only R1, it has been sending to as a designated router. Consider here R1 as a designated router. If R5 wants to communicate to R6, it sends a traffic to R1, and then R1 will transmit a traffic to R6. So, it helps to avoid huge OSPF traffic. Every router is being connected to DR. Instead of connecting to all other routers fully mesh, it will just connect it to the DR, and DR will retransmit to whichever router they are being used. So all traffic from the router will be sent to the DR, and DR will reply to all the routers. And what is the use of backup designated router, which is nothing but a BDR? When DR crashes, BDR takes the role of the DR. So that's what BDR is used. Next, how DR and PDR elected. So by which manner we choose which router will become DR and which router will become DR. Let's think of it. Okay. By default, it is based on the priority. So DR and BDR is mainly based on the priority. Who's having a higher priority will become a DR, and a second higher priority will become a BDR. So by default, every router has a priority of 1. Higher priority will be elected as DR, and the second higher priority will be elected as a BDR. Suppose consider if every router having a same priority, consider to be as a default priority of 1. Every router is having a default priority of 1. So which router will become DR? If you think in the sense, the tiebreaker will be the router ID of a OSPF. So OSPF router ID will become a tiebreaker. So automatically the router which has a router ID, the highest router ID, that is highest IP address of the router ID, will become the DR, and the second router ID, second highest router ID will become the BDR. So all other routers will have to send the information to the DR, and DR will reply back to this. Suppose if you want concerned routers, suppose if R5 and R6 should not ever become a DR and BDR, what you have to do is just change the priority value of R5 and R6 to 0. So the router that has a priority of 0 will never be participate in the election, and hence it will not become a DR and BDR. So this is how the DR and BDR election goes on, and this is the manner it will select which router will become a DR and BDR, whether they can participate in the election or not. Next is about areas. So as I said earlier, area 0 is said to be as a backbone area, and the routers that belongs to the backbone areas are said to be as a backbone router. Which is a backbone area? The area 0 is said to be as a backbone area. So all other areas are considered to be as area 1, 2, 10, 15, 20, 25, whatever be the area, they should have to be connected to area 0 directly or indirectly. Whichever manner it has to connect to the area 0. Otherwise the routing will not happen. Another important main terms you should have to remember is ABR and ASBR. So what is an ABR? ABR is nothing but an area border router. The router that connects two areas is said to be as area border router. To be more simpler, the router that has a configuration of two areas is said to be as ABR. And what is an ASBR? Autonomous System Border Router. Is said to be as a router that has two routing protocols, that has a routing protocol other than OSPF. Suppose you are using a routing protocol OSPF, that is a default in terms of OSPF, and other routing protocol as RIP or EAGP, whatever you are using. So that router is said to be as a ASBR. So this is about areas, ABR and ASBR. Next about OSPF commands. So you should know about these are the basic OSPF commands. And show IP OSPF neighbor. It gives you information about a neighbor, that is a neighbor ID, DR, BDR, and what is a neighbor's router ID, and what is the state. It is a DR or BDR or a local interface that it is being connected. This is what a neighbor gives. And in case of show IP route OSPF, it gives you information about a routing table of OSPF, that is which network and the AD value and a metric and local interface. And main important thing about OSPF is show IP OSPF interface command. So it gives you about a cost value, which area you belong, and which process ID you have configured, and router ID and network type. These are the information that the show IP OSPF interface command will give you. So I hope you understand this about the basics of OSPF. That's it. If you have any doubts or queries, just give a comment. Thanks for watching. Until next time.